right, this question says calculate the amount of carbon dioxide produced if 3.45 moles of heptane is burned. First of all, we have to recognize that when we're burning something, this is a combustion reaction. For a complete hydrocarbon combustion, so this is in your data books, it's your hydrocarbon plus oxygen gives you carbon dioxide and water. It's always the same two products. You don't need to memorize that. It is given to you. So we're going to set up our equation. So we have our hydrocarbon, which in this case is heptane. The formula for heptane, so for an alkyne, we have CnH2n minus 2. So that means we take the number of carbons, double it, and subtract 2. So for heptane, that's 7 carbons times 2 minus 2 gives us H12. The rest of the equation is the same for every hydrocarbon, CO2 and H2O. Now we have to balance, so I need a 7 here to balance my carbons. I've got 12 hydrogen, here I only have 2, so I need 6. This gives me a total of 7 times 2 is 14, plus another 6 oxygen gives me 20, so I need a 10 here to balance. Now the rest of the equation, we're going to be using from page 10 on our data books, this formula. I've got number of moles of my required is equal to number of moles of my given times coefficient of required over given. So that's why we have to balance this first. So number of moles of my given equals number of moles of my required equals number of moles of given times coefficient of required over coefficient of your given. Okay, number of moles of my required, it's asking for how much carbon dioxide is produced. This is my required. I'm given 3.45 moles of heptane. So this is my given. Number of moles of CO2 equals number of moles, 3.45, of my heptane, C7H12, times my coefficients. Coefficient of my required carbon dioxide is 7. It's my required over 1, my given. So we take 3.45 and multiply it by 7 over 1. And we get 24.15 moles of CO2, which we're going to round to 3 significant digits because that's what I'm given in the question. So we get 24.2 moles of CO2 being produced.